All right, so in this section, we're going to be talking about quadratic equations and applications. We will solve quadratic equations by factoring. We will solve quadratic equations by factoring out square roots, extracting square roots. We will solve quadratic equations by completing the square, using the quadratic formula, and then real-world problems. In other words, word problems. So recall that a quadratic equation takes the form ax squared plus bx plus c equals 0, where a is not 0. If a was 0, it would no longer be a quadratic, it would be a line. Quadratic equation is also called a second-degree polynomial because the highest degree on the exponent, the highest degree variable is x squared, so second degree. So we're going to look at four methods of solving these: factoring, extracting square roots. You might have heard that in the past been called the square root method, completing the square, and the quadratic formula. First of all, let's talk about the zero factor property. If I have two numbers, a and b, if I multiply a and b together and get 0, one of two things must be true. Either a is 0 or b is 0, or maybe even they're both 0. So the only way to multiply products together and get 0 is if one of those factors happens to be 0. So let's factor this. I have 2x squared plus 9x plus 7 equals 3. Well, the first thing I have to do is I have to set it equal to 0 because that's where the zero factor property falls in. This currently does not equal to 0. And you can't just say, well, these two together equals 3. It doesn't work that way. They've got to be 0. So to set this equal to 0, I need to subtract 3 from both sides. That gives me 2x squared plus 9x plus 4 is equal to 0. And now we have to factor this. All kinds of different ways of factoring, box method, slide over method. There's all kinds of methods. But ultimately, I'll do this one by grouping. What is important is I need two numbers whose product gives me 8. I took a, which is 2, and c, which is 4. If I multiply 2 times 4 together, I get 8. And notice that b is 9. So I need to get a product of 8 and a sum of 9. Well, the two numbers you can multiply together to get 8, but when you add them together and get 9 would be 1 times 8 is 8, and 1 plus 8 is 9. So the two numbers are 1 and 8. So I'm going to rewrite this quadratic as 2x squared plus x plus 8x plus 4 equals 0. I did not change the value of the quadratic at all. I simply broke that 9 up into a 1 plus 8. Now we're going to factor by grouping. This first group has an x in common, so I'll factor out an x, leaving me with 2x plus 1. My second group, I can factor out a 4, which leaves me with 2x plus 1. I now have two terms here, and both of these terms have a 2x in common. So I'll factor out the 2x plus 1. And when I factor out that 2x plus 1, like they're not even there anymore, the only thing that's left is x plus 4. So now I can use my zero product property. I have two things, if you will, that are being multiplied together to get 0. And the only way this can be true is if 2x plus 1 equals 0 or x plus 4 equals 0. To solve the 2x plus 1 equals 0, I would subtract 1 from both sides and then divide by 2 and get negative 1/2. To solve x plus 4 equals 0, I would subtract 4 from each side. X equals negative 4. So that means the answers for this are the set containing negative 4 and negative 1/2. And best practice would be to take both of those answers and substitute them into the original problem to see if you get a true statement. So I would plug them in for x squared and for x. So I have 2 times negative 4 squared plus 9 times negative 4 plus 7. Does that equal 3? And then I would do the same thing with negative 1/2, okay? Solve this one by factoring. First of all, it's already in general form. And I look at this. So I've got 6x squared minus 3x equals 0. Don't forget that the very first step to factoring is always look for a common factor. In this case, I don't have a constant, so I can, in fact, factor out at least the x. But in this case, I'm going to factor out a 3x. So 3x times 6x squared divided by 3x, that's 2x, minus 3x divided by 3x is 1. And so it's factored, which means either 3x equals 0 or 2x minus 1 equals 0. To solve 3x equals 0, divide both sides by 3, so x equals 0. To solve 2x minus 1 equals 0, I will add 1 to both sides. 2x equals 1, divide by 2, x is 1/2. So my answers for this problem are the set containing 0 and 1/2. And again, best practice, go back up, plug those in, and see if they do in fact give you a true statement. If they don't, go back to the drawing board and see where you might have messed up. The zero factor property applies only to equations written in general form. That's why 2 problems ago I had to put that in general form by subtracting 3 from both sides. So all terms must be collected on one side before factoring. For instance, in the equation x minus 5 times x plus 2 equals 8, we cannot set those factors to 8. What we would have to do instead would be to multiply the binomial on the left side, combine like terms, subtract 8 from both sides to set it equal to 0. Then we could work that. All right, so let's go ahead and solve that problem. I went the wrong way. 1 second. Sorry about that. X minus 5, x plus 2 equals 8. Okay. Foil this. First times first, x squared. Outside times outside is 2x. Inside times inside is negative 5x. 2x minus 5x is minus 3x. Minus 10, last times last, equals 8. Subtract 8 from both sides. X squared minus 3x. Subtracting 8 from both sides, negative 18. Okay. 2 numbers that multiply to get negative 18, but combine to get negative 3. That would be negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So this factors into x minus 6, x plus 3. And a reminder on this one, I did not have to do grouping because a was 1. When a is 1, once you find your two numbers that multiply to get AC and add to get B, you're pretty much done. You don't have to worry about separating it and grouping and all that stuff. This means that either x equals 6 because 6 minus 6 is 0, or x equals negative 3 because negative 3 plus 3 is 0. So the answer would be negative 3 and 6. Plug those into the original problem and see if you get a true statement. Another method of solving quadratics is called extracting square roots. This is useful when b is 0. So if you have like ax squared plus c equals 0. When you have that situation, you can isolate the square root. Isolate the x squared, take the square root of both sides, and get the answer. So in past classes, you might have talked about this as being the square root method. this text calls it extracting square roots. So if I can get a quadratic to look like u squared equals d, as long as d is not zero, is greater than 0, I can actually get u squared equals d. I can take the square root of both sides, and that would be the answer. They actually pull the d over and factor it by saying that the u squared minus d factors into u plus d and u minus d, and you can see that we're going to get the same answer. And I'll work it both ways to show you. So set those equal to 0, and your answers are going to be plus or minus the square root of d. Solving the equation in the form u squared equals d without going through the steps of factoring is called extracting square roots. Extracting square roots, u squared equals d. You take the square root of both sides, the square root of positive d and negative square root of d. So you're going to get u equals plus or minus the square root of d. So here's a problem. Here's two problems. Letter A, I have 4x squared equals 12. Well, I don't have a b term. Well, that's a good thing. So because all I have is my quadratic and my constant, I can solve this by extracting square roots. So the first one, 4x squared equals 12. If I was to divide both sides by 4, that would get me x squared equals 12 divided by 4 is 3. So x squared equals 3. And in this case, if I was to take the square root of both sides, the square root of x squared is simply going to be x. All right, back in that prereq section, we talked about square roots. And we said, well, the square root of 4 was 2. Think about what's going on here. I am solving a quadratic. Because this is a second degree polynomial, a second degree polynomial must have 2 solutions. Sometimes it's the same number, called a double root, but a quadratic must have 2 solutions. Well, if the square root of 3 is only the square root of 3, then how do I get 2 solutions out of that? Well, the answer is we have to think about the fact that the square root of 3 times itself is going to get me the square root of 3. I misstated that. Whatever the square root of 3 is, 1.7 something. That 1.7 something times 1.7 something is going to get you the 3. Okay? But also, negative 1.7 something times negative 1.7 something is going to get you that same answer. So when you're solving quadratics, we will go ahead and put in that plus or minus. So since 3 is not a perfect square and I can't simplify this, I will write my answer as plus or minus the square root of 3. And that is going to be the value for x. Doing the same thing with part B. So it looks a little different here, and that's okay. Notice that x minus 3 is being squared, and that equals 7. I can take the square root of both sides of that. Because the square root of x minus 3 squared is going to be x minus 3. And the square root of 7, just like I talked about a minute ago, is going to be plus or minus the square root of 7. To get x by itself, I will add 3 to both sides. So that gives me x equals 3 plus or minus the square root of 7. And again, plug those in, see if it works out. If it does, you're good to go. That last problem we did kind of leads us into completing the square. It says, suppose that the equation x minus 3 squared equals 7 had been given in the form x squared minus 6x plus 2 equals 0. So what that's saying is the equation x squared minus 6x plus 2 equals 0 and x minus 3 squared equals 7 are actually the same equation. And they're both going to have the same answers. x squared minus 6x plus 2 is not factorable. So factoring this is not an option. And that's where this method called completing the square comes in. Any quadratic can be solved by completing the square. All of them. Completing the square always works. It's just a little extra work. So let's look at how this completing the square process works. To complete the square, if I have a quadratic that has an ax plus bx, a squared plus bx, notice I'm ignoring the c right now. If I have a squared plus bx, if I take my b and divide it by 2 and square that, and add that to the a squared plus bx, that makes this will be a perfect square. A squared plus bx plus b over 2 squared will always factor into x plus b over 2, which is what it says right here. Okay? So we are being very specific in taking half of a b and squaring that value. By doing that, we're making it a perfect square. It might not be pretty. It might not be integers like we're always happy with. We might have a lot of fractions and stuff, but it's okay. It's going to work. We are going to solve that same problem we just did by completing the square. Okay? Notice the leading coefficient is 1. To complete the square, that leading coefficient, the number in front of x squared, has to be 1. If it's not a 1, you've got to make it a 1, and that gets even hairier. So to complete the square on this, and again, I'm going to work it in a method that I'm familiar with and comfortable with. This particular text might work it a little different. Feel free, go back and look at the notes from the text and see how they worked it and compare the two. Okay? To complete the square on this, what I'm going to do is I'm going to take that 6 and add it to both sides. So I want x squared plus 2x. I'm going to leave it alone. I'm going to leave a little bit of space here. By adding 6 to both sides, I get a 6 on the right side. So now let's figure out what we need to add. For this problem, b is 2. If I took b and cut it in half, half of 2 is 1. And if I took that half of b and squared it, well, 1 squared is 1. So what I need to do here is I'm working with an equation. So remember, if I do something to one side, I have to do the exact same thing to the other side. I'm going to add a 1 to the left side. But if I add a 1 to the left side, I must add a 1 to the right side. I made this into a perfect square. And it factors into x, and then whatever this guy is right here, in this case it's a 1, plus 1 squared. That's how it factors. Equals 7. And if you've been paying attention, x plus 1 squared equals 7 is the exact same problem we were working on part B on example 2. Okay? So we would take the square root of both sides. X plus 1 equals plus or minus the square root of 7. Add 1, subtract 1 from both sides. X equals negative 1 plus or minus the square root of 7. Okay? There you go. I think that was actually a different problem from number 2 a while ago. But we can check our answer by taking that negative 1 plus the square root of 7, plug it into the original, see if it works, and then we would do the same thing with negative 1 minus the square root of 7 and plug it in. And when you plug both of those in, you're going to see that they do, in fact, both check, and so they are both good answers. When the leading coefficient is not 1, you must divide out whatever that coefficient is before you complete the square. I don't have an example of that right now, but if one pops up and you want me to work one for you, I'd be more than happy to. So completing the square, like I said, always works. When a is not 1, it gets really, really messy, and it can take quite a bit of time to solve. You're going to have to think about factoring out a fraction or whatever. It always works, but it's like math. We always have different ways of doing things. Another method that always works is the quadratic formula. And in the last lesson, we did a problem with the quadratic formula. Quadratic formula always works. The quadratic formula is very, very systematic. Plug in and go. So many times I think the quadratic formula is going to be an easier approach than completing the square. So let's take a look at the quadratic formula. As I did in that previous section, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's the formula we're going to be using. It's a good idea to memorize that formula there. So we can read that as negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The part inside the quadratic is called the discriminant. So the discriminant is b squared minus 4ac. And as you noticed earlier, when I worked a problem using the quadratic formula, I calculated the discriminant separately and kind of worked 2 problems and then put that back in. It makes the math a little cleaner as you're working through a problem. So the solutions of a quadratic equation, ax squared plus bx plus c equals 0, can be classified like this. If the discriminant is positive, a positive discriminant tells you that you will have 2 real roots to your problem. If the discriminant is 0, you will have 1 real root, and that would be called a double root because it's actually counted as twice. There's only one x-intercept for that graph. If the discriminant is negative, well, in the real world, we can't take a square root of a negative number. So if the discriminant is negative, we will have 2 complex roots. No x-intercepts. Okay. And also know that to use the quadratic formula, you must first write the quadratic equation in general form. Ax squared plus bx plus c. Writing it in general form allows you to identify your a, b, and c to solve the problem. So we're going to use the quadratic formula to solve x squared plus 3x equals 9. Notice it's not in general form. We must subtract 9 to get it into general form. X squared plus 3x minus 9 equals 0, which means a is 1, b is 3, c is negative 9. Our quadratic formula tells us that the solutions to this is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And again, I will work the discriminant off to the side. B squared minus 4ac. B is 3 squared minus 4 times a, which is 1, times c, which is negative 9. 3 squared is 9. And then I have a negative 4 times 1, which is negative 4. Negative 4 times negative 9 is plus 36. And 36 plus 9 is 45. My discriminant is positive. I will have, so this is positive, which means I will have 2 real roots. 2 real zeros. 2 real x-intercepts, right? Okay, so let's go ahead and find them. X equals negative b. Well, b is 3, so negative b would be negative 3, plus or minus the square root of 45 over 2 times a. Well, a is 1. 2 times 1 is 2. Square root of 45. Well, the square root of 45 can be simplified because the square root of 45 is the same thing as 9 times 5. And I chose 9 because 9 is a perfect square. That's divided by 2. So x equals negative 3 plus or minus. The square root of 9 is 3, so it comes out. Square root of 5, leave it alone, all over 3, all over 2. And folks, that's it. You can't do anything else. So the two answers are, the first answer is negative 3 plus 3 square roots of 5, all divided by 2. The other answer would be 3 minus 3 times the square root of 5, all divided by 2. And I think when you're doing your homework, you actually have to enter those as two separate answers with a comma in between them. So make sure you know that is the two answers right there. You can check it by taking those answers, plugging into the original problem, and see if you get the correct answer. Applications. So we're going to talk some word problems here. Quadratics are very useful in solving problems when you're talking about area. Here's an example. I have a room. The room has an area of 144 square feet. What are the dimensions of the room? Well, because the room is a square and I don't know the length of the side, I could say that x squared is 144. Well, this is a quadratic, so a quadratic has two answers. If I take the square root of both sides, I get x equals plus or minus 12. Well, that doesn't make sense in the real world. You can't have an area of negative 12. So we throw that one out and we keep the positive 12 to conclude the dimensions of this square room are in fact 12 feet long. And this is what I just mentioned. Although x squared equals 144 does have two solutions, 12 and negative 12, a negative solution does not make sense. So we choose the positive. So here's a problem. It says a rectangular sunroom is 3 feet longer than it is wide. See the figure below. And has an area of 154 square feet. Find the dimensions of the room. So they were nice to us on this problem. They gave us a picture. They told us the width of the room is W, and the length of the room is W plus 3. Well, to find the area of a rectangle, the area is length times width. Well, here's what they've told us. They've told us the area is 154. They've told us the width is W plus 3, and they've told us the width is W. Well, it looks to me like this is a quadratic. I can distribute that W. I'm going to flip it around too. Distributing the W gives me W squared plus 3W equals 154. Now to solve this, I need to set it equal to 0. So I will subtract the 154 from both sides. Equals 154. So here we are. I need two numbers whose product, A times C, well, A is 1, so that's pretty simple. C is negative 154. So I need two numbers that multiply together and get negative 154. Well, when I add them together, I get B, which is 3. Two numbers that multiply to negative 154 and add to 3. Well, that tells me that to get a product that's negative, I have to have a positive and a negative. To add them together and get a positive number tells me that the bigger number, and I'm saying that, in quotes here, the bigger number has to be positive. I believe it's 14 and 11. 14 times 11 is 154. So I need the bigger number. I need the 14 times negative 11. That's going to give me the negative 154. And 14 plus negative 11 gets me the 3. So my numbers are 14 and negative 11. And again, because my A is 1, I don't have to worry about grouping or anything. I can go ahead and write this down. I have W minus 14 times W plus 14 times W minus 11 equals 0. Well, for W plus 14 to be 0, that would mean that the width is negative 14, because negative 14 plus 14 is 0. That doesn't make sense. I can't have a width of negative 14. However, W minus 11, that would be a width of 11. 11 minus 11 is 0. So the width of this room is 11. I throw away the negative 14. But the negative 14 is kind of important if you think about it, because the length is W plus 3, which is 11 plus 3, which is 14. So this question says, find the dimensions of the room. Here's the answer. The dimensions are, the dimensions of the room are 11 feet wide by 14 feet long. And there's your answer to this question. Check it out. 11 times 14. Yes, that's 154. 14 minus 3 is 11, so it does set to the problem. Good to go. Another common application of quadratic equations involves an object that is falling or a vertical or projected into the air. General equation that gives the height of such an object is called a position equation. And the position equation for Earth is negative 16t squared plus v naught t plus s naught, or s sub 0. So negative 16 is your coefficient of gravity. T is time. V sub 0, that is your initial velocity. How fast is it going at the start? And S sub 0, or S naught, that is going to be where does the item start? Okay. A third application involves the Pythagorean theorem and triangles. So you'll see this quite a bit. Gives you one or two sides. Gives you two sides of the triangle. You got to find the third. That's going to involve quadratics. And folks, that is it for the lesson for this section. I'm now going to work the practice problems. So if you would, or you can stop and work with them on your own and then come back and see what I've done, or you can just stay online and watch it right now. Okay, so number 1 says solve by factoring. I'm going to put it in general form first. So I will add 4 to both sides. X squared plus 4x plus 4 equals 0. I need two numbers. My AC is equal to 1 times 4, which is 4. I need a product of 4. My B happens to also be 4. Okay, so I need a product of 4 and a sum of 4. Well, that's just 2 and 2. 2 times 2 is 4. 2 plus 2 is 4. So this factors into x plus 2 times x plus 2, which means x equals negative 2 or x equals negative 2. And that's kind of redundant. This is actually called a double root. So x is just going to be negative 2. Negative 2 is the only number that you can plug into that and get a correct answer. Number 2, solve the quadratic equation by completing the square and extracting roots. Okay, so let's start by completing the square. B is, first of all, A is 1, so I'm good to go on completing the square. I can just press on. My B is negative 4. If I take B divided by 2, I get negative 2. If I take that B divided by 2 and square it, I get 4. So to complete the square, I'm going to have x squared minus 4x. I'm going to leave a space. I'm going to have to add something to it, plus something, equals, I'm going to add 5 to both sides. Move that 5 over to the other side. But because I added something to the left side, I have to add something to the right side. So what do I have to add to complete the square? Well, to complete the square, I've got to add half of b squared, which is 4. So if I add 4 to the left side, I add 4 to the right side. Because I was very specific in choosing that 4, it factors easily. This is going to factor into x minus 2. And again, look at this negative 2. There it is when you're factoring, okay? So I have x minus 2 squared equals 9. So I've completed the square, and now I'm going to go ahead and extract the roots. So to extract the roots, I will take the square root of both sides. Doing so gives me x minus 2 equals, and remember, because we're solving a quadratic, the square root of 9 is going to be plus or minus this time, okay? 9 is a perfect square, so it's going to be plus or minus 3. I will add 2 to both sides, so x equals 2 plus or minus 3. Now, in problems in the past, we ended up with like a real number, a constant plus or minus a radical, and we couldn't combine those. Well, folks, this is two constants. I can combine these. So x equals 2 plus 3 or 5. X equals 2 minus 3. 2 minus 3 is negative 1. So the answer to this question is the set of numbers containing negative 1 and 5. And we could plug those in to see if it actually works, just to check our answer. Number 3, solve by completing the square and extracting the roots. Okay, well, on this one, excuse me, A is not 1, so this is going to be a little bit complicated. However, 9, negative 6, and negative 15 are all multiples of 3, so I'm going to go ahead and divide everything by 3. I'm going to divide both sides of the equation by 3. This is legal because it's an equation. So I'm going to rewrite this as 3x squared minus 2x minus 5 equals 0. So to complete the square, I'm completing the square on this part right here, which means to make A a 1, I must factor out a 3. I'm not talking about that minus 5 right now because I'm about to add it to the other side. So to factor a 3 out of this, and you're factoring out whatever A is. Whatever A is, that's what you're factoring out. So I'm going to factor out a 3. And when you're doing that, ask yourself, okay, I'm dividing by 3, okay? So looking at 3x squared, 3 divided by 3 is 1. Well, that's nice. So I have x squared. Minus, what's 2 divided by 3? Well, 2 doesn't divide by 3. So 2 divided by 3 is 2 divided by 3. And there's my x. Okay? Now, I'm going to complete the square on x squared minus 3x. Remember, to complete the square, I'm going to have to add something. Okay? Now let's go ahead and take care of that minus 5. Adding 5 to both sides, I have a 5 on the right side. Because I added something to the left side, I have to add something to the right side. And folks, again, I do completing the square different from how it's done in your examples, how it's done in the book. Read through the book's way, look at my way, choose the one you like, and go with it. All right. So, again, I'm completing the square on whenever A is 1. So I'm completing the square on x squared minus 2/3 x plus whatever, which means B is negative 2/3. B is not the negative 2 that I started with. It's not the negative 6 I started with. B is whatever it is when I get A to be 1. Half of B. Well, if I took negative 2/3 and took half of it, or multiplied it by half, right, because of means times, I would get negative 1/3. But now I need to take that half of B and square it. Negative 1/3 squared would be positive 1/9. So I will now add 1/9. Now here's where you have to be careful. Did I add 1/9? Well, notice the 1/9 is inside these parentheses. This 1/9 is being multiplied by 3. So I didn't actually add 1/9. I added 3 times 1/9. I added 1/3. So because I added 1/3 to the left side, I have to add 1/3 to the right side. So think of it as taking this 3 times, picking up this 1/9, and that's what's going right there, okay? Now, because I was very specific on adding 1/9, this ugly fractional quadratic will factor. Here's my 3. I'm keeping it. That quadratic will factor into x minus 1/3 squared equals 5 is the same thing as 15/3. 15 divided by 3 is 5. And 15/3 plus 1/3 would be 16/3. So now I need to extract the roots. So I need to get rid of that 3. I need to get rid of this 3 right here. I will divide both sides by 3 or multiply both sides by 1/3, however you want to look at it. That leaves me with x minus 1/3 squared equals 16/9. Taking the square root of both sides, I get x minus 1/3 equals plus or minus the square root of a fraction is the square root of the numerator divided by the square root of the denominator. The square root of 16 is 4. The square root of 9 is 3. I will add 1/3 to both sides. So x equals 1/3 plus or minus 4/3. So x equals 1/3 minus 4/3. 1/3 minus 4/3 would be negative 3/3 or negative 1. 1/3 plus 4/3 is 5/3. And so x is equal to that set of numbers, negative 1 and 5/3. Part 4, solve by the quadratic formula. It's already written in general form. A is 1, B is 8, C is negative 4. Do the discriminant, b squared minus 4ac. Well, b is 8, so 8 squared is 64. Minus 4 times 1. 4 times 1 is 4. Negative 4 times 1 is negative 4. Times negative 4 would be plus 16. 64 and 16 is 80. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals, make some more space to write real quick. Negative b, that would be negative 8 plus or minus, I've got the square root of 80. Perfect squares in 80. Well, 16 times 5 is 80. So that'd be the square root of 16 times 5, which would be 4 root 5. 4 square roots of 5. All over, 2 times 1 is 2. If you'll notice the top, I can factor a 2 out of it because everything is even. I could actually factor a 4 out, but since all I have on the bottom is a 2, I'm just going to worry about factoring out that 2 on the top. So factoring out a 2 on the top gives me negative 4 plus or minus 2 square roots of 5 all over 2. Those 2's cancel. So final answer is negative 4 plus or minus 2 square roots of 5.